Welcome to the ZoomTown experiment. I'm back from a long break from the project, and I've got some promising news to share with you all. So welcome back. I need to give a shout out to Steve Woodgate. Steve has been a follower of this project and the channel for a very long time now, and he's contributed some really great ideas to help move the project along. He's also provided some good financial backing, and he just made another very generous donation to the channel. So thank you very much, Steve. I really appreciate it, and it definitely helps, especially now that I'm retired. All the rest of you viewers, I really appreciate you guys. You show up every time I've got a video out there, you watch it. Many of you give me a thumbs up. That really helps the channel grow. Commenting helps the channel grow, and most of you are already subscribed. If not, please do so. That will all help feed the beast that is this channel, and I can keep providing more and hopefully better content. But let's get back to where we're at with the ZoomTown experiment. The last video, which was about 3 months ago, was just yet another failed attempt at getting extremely accurate positioning while the Zoomie is moving. And since then, I took about 2-3 months off from filming and development to just clear my head and try to understand what's really going on here. I knew from the beginning this was going to be a near impossible task, but I honestly expected to have better results than we already have had. So I thought, well, first let's understand why this is failing, and then maybe we can figure it out from there. So I'm going to take you on a real quick slideshow presentation that'll kind of help explain how we got where we are and what I think I need to do next, and then I'll show you some results of that effort. The project started out that I was only going to use encoders to track the position of the Zoomie. Then at some point, that wasn't accurate enough. The Zoomie and the encoders just wouldn't keep an accurate enough track of where it was. And so we added road end markers, which was a piece of black tape at the end of every road section. Well, then I tried that out. It showed promising results, but then I added zero set marks where every time I started on a road, I would had a magnet and a piece of tape, and that was a flag to the software to reset the zero position right at the start of the roadway. Well, that helped in that regard, but then I found out that as the Zoomie's progressing along a very long distance, due to errors in wheel size and poor counting of the encoders and so forth, I needed to update literally every inch along the way, and that caused an enormous task for me to apply equally spaced 1 inch apart pieces of tape across every road surface along the guidelines. And you'll see that in any images of ZoomTown, they look like railroad ties where the Zoomies are traveling. Ultimately, that did help a lot, but it didn't solve all the problems. The next step was to have position set markers. I needed to know the absolute position relative to some landmark in ZoomTown, and I could never do that with just incremental movement and incremental tracking. So we added position set markers at certain locations that would have a magnet and a piece of tape, but the magnet would be on the opposite side of the Zoomie. Well, that didn't solve the problem. Then we added QR codes, and that was a real game changer. It allowed me to look at a QR code, and on that code, it would tell me the exact X and Y location the Zoomie was at, as well as the road name, via just scanning that code. And I could put them at any location along anywhere the Zoomies drive. And that solved another substantial problem. I will say it has been a little bit hit or miss to get the QR codes to read consistently, so I couldn't rely on those as much as I would like to. So with that, ultimately, we just had too many layers. If we go back to that slide, seriously, you look at all that data there stacked on top of each other, it's hard to make rhyme or reason of what was going on. But that is a very typical trap that when solving problems, you keep adding solutions and getting improved results, but you're adding complexity and ultimately you're adding more problems in an effort to solve the first problem. So I really, in looking at it, I'm saying there's just simply too much complexity for what we're trying to achieve, trying to get our objective. So I shouted to myself, stop, I've lost my way. Where did I get lost? Obviously with adding all those features and abilities. So it's time to take a reset. You got to clear your mind, and that's what I've been doing for the past month or so. With that reset, I focused on simplifying everything. Get back to the basics, get back to the fundamentals. And for those of you that have been in business, you know the kiss it principle. Keep it simple, stupid. Simplify everything, go back to the fundamentals, and start over. And so with that, I needed to focus back on what was the original problem I'm trying to solve. The original problem, I need to go from one driveway to another. Ultimately, I need to get to a destination. That is the most important thing. I need to get to that destination. How I do it isn't necessarily important. Keeping track of within less than a millimeter precision of any point along the way is sort of irrelevant to the main objective. I have to get a Zoomie into the driveway at the destination with absolute reliability. So that's where I backed up my entire thought process to. Let's just focus on that and we'll figure everything else out along the way. But something magical started to happen. Things started to work. Now, as I explain what I changed and how things are changing, what I want to do is I'll show you a graphic somewhere up here, and it's a video of a series of tests that I performed in the past few days testing out this newer idea, this newer concept. And it involves two maneuvers, driving straight and then making a pivot turn to line up with going into a driveway or onto another road. That's all this test is doing, but I'm doing it across 5 different locations, 4 driveways and 1 T intersection to go onto a road. And to make it a little more interesting and a little more practical, I changed the start point of the Zoomie for each test I run. So I might move it back a ½ inch, forward a ½ inch from the proper start point, and that way I'm introducing variability to where the Zoomie is coming from, which may or may not affect the endpoint. I have to be tolerant that that cannot affect the endpoint. The endpoint to make that turn has to be absolutely perfect, or as close as we can get here in ZoomTown. So you'll see that when I'm launching the Zoomie, I'll vary the start point to introduce variability. Areas I want you to pay attention to in these videos is the stop point before turning. That is critical. You probably won't be able to detect or verify that too well by eye with the video and the camera angle, but it has to be very accurate so that the next move, when the Zoomie pivot turns 90 degrees fully, that it is on center line to enter the driveway or to enter the next road. And that is where you can observe how accurate this new system is. That end result is to have 2 black marks centered over the white line which is the primary observation and test that we're performing. Those two black lines on the Zoomie are just two pencil marks. And then, of course, the white line is the line following guideline to pull into the driveway and ultimately as well to back out of the driveway. So with that, we'll get those videos running up in the corner. I'll move myself down out of the way, and I'll explain to you what's been going on. To get to another destination, the Zoomie has to follow a path and stop at the precise position to turn into the driveway, at least for this test. Line following has been very reliable using the TCR T5000 photoreflective sensors, two of them, one on each side of the guideline, and that keeps the Zoomie on course. The weakness has always been stopping at the precise location, often, especially when making a turn. The new encoders that I implemented a few months or a few episodes ago have been tracking pretty good. They're far better than the original system I was using with the encoders back then. The new encoders have been tracking pretty good, and I've been testing that for a couple of days now. And in tests that I've done recently, the Zoomie was within a 0.2% repeatability and accuracy of the travel. My test was for to move 53 inches and stop at a specific point. With that, I could stop consistently within 0.11 inches, or about 4 millimeters. We know that isn't good enough for what we need to do with the Zoomie, but at least it can get me very close to the location where I need to stop. So what I'm doing now, I move to that destination using encoder feedback. But at about 1.5 inches short of that destination, I will decelerate so I can scan more frequently and more accurately as the Zoomie moves along. And I'm looking for a marker at that point, piece of tape across the road. And because I'm moving slow, when I experience that encounter, the Zoomie can stop literally within a few thousandths of an inch of that location. So if we extrapolate it out, make it a little more gross than what I'm physically measuring, I would say we're within a 1/16 of an inch, which is 15 thousandths of an inch, which is less than half of a millimeter. That's how accurate that was working. So I'm confident that the encoders can help me out as long as nothing changes there. Now at that point, I can achieve positioning to the right point to make the turn into the driveway or onto the next road section. Now the pivot turn presents yet another series of problems that require a more creative approach. The pivot turn uses only one wheel to create the motion. If I'm turning left, the right wheel will rotate, causing it to pivot on the left wheel. Now, of course, it is pivoting, there's frictions involved, so you get quite a bit of variability in that maneuver. So the process has to be tolerant of that. But I'm still using the encoder to tell me how far it moved. Now, at the endpoint, which is the most critical, there were a number of different processes or methods I could use to find that endpoint. Encoders wouldn't be accurate enough, but I could take one of the photoreflective sensors and look for the white line, and then try to sense where the white line begins and then ends. And at that point, if I'm making a left turn using the left photosensor, I could see that and then stop. That test proved to be a failure. It didn't balance centering very well, because you will get variations in photoreflective feedback based on any changes in an ambient light or other conditions. So then the next concept was to use two photoreflective sensors, keep pivoting, slowing down before I get in range of where the endpoint should be, and then get an exact number for both the left and the right photoreflective sensor. That actually worked pretty good, but it was never on center. That's primarily because the left and right photoreflective sensors are not all that precise and perfectly matched to each other to give me the same feedback. So I had to add in an offset value to the right side that would shift the centering mathematically to get it lined up perfectly on center. With that, once I implemented that and I continued my testing, I was amazed as to how good it was repeating. And you're seeing that in the video up there, and you're seeing it hit probably within, if I were to measure side to side, looking at the black lines against the white line, I would bet I'm within a quarter of a millimeter or about 10,000ths of an inch. It's just been rock solid, consistent, which is awesome, really awesome for what I need to do here. That will solve a massive amount of problems that I'm experiencing. With these positive results, I'm moving forward with more testing in this little straight section of road with these 5 locations. I want to get a full process put together so that the Zoomie pulls forward, makes a pivot turn, pulls into the driveway, backs out of the driveway, pivot turns again, goes to the next location, and so on. I've done similar tests like this, and it's been very successful, only to fail at a later point in further testing. But it is a very good test, and that'll continue for the next probably week or so. And then from there, I'm going to pull up all the tape, all the QR codes, and all the other stuff from the opposite side of the road. And instead of heading in ZoomTown north, I will head south in ZoomTown on the same road, repeating the same tests. From there, if that proves positive and very reliable, then I'll continue that change across the rest of ZoomTown stage by stage, testing each phase along the way. I'll give you an update video once I get further along with that process, but it's very time consuming. That test that I filmed yesterday took just about the entire day, doing the setup, getting everything ready, running the test after test after test after test, exploring what I see, making a change if necessary, and then repeating the tests again. So where we're moving forward right now is that I'll continue this testing, and in a few weeks, I hopefully will have enough information to do another update video to say whether we're moving forward or we're stalled again. I'm really hoping it'll move forward because everything is getting more simple, and with that simplicity, I'm seeing much better accuracy. Now, I will add one caveat to this. When I originally conceived the idea of the ZoomTown experiment, I was very much against the idea of doing it this way. I didn't like the idea of putting a marker right at the point where I needed to turn. To me, that was cheating from the overall concept of the Zoomies being autonomous, etc. But as I look at all these other markers I've freely added to ZoomTown in the past year, the 0 set markers, position set markers being the magnets with Hall effect sensors, the inch markers, the tape at other locations for endpoint markers, the QR code reader, all of that, well, it was still somewhat autonomous, but they're additional markers. So I've justified to myself, based on the success of this latest experiment, I'm okay with just putting a single marker at the actual endpoint. And with that, everything else will hopefully fall into place. So to me, this is really exciting. It's a huge step forward. And it's becoming a little bit more understandable, the code, the process, what's really happening. And with that, it should give me enough leeway to move this whole project forward. So I would love to absolutely hear your thoughts and comments on this so that if you got questions, ask them in the comments below, or your thoughts or suggestions as to how we got where we are and where we're going now. So with that, I'm going to wrap up this video. Thanks so much for watching, and I look forward to seeing you in the next one. It's kind of caught me off guard, y'all. And then I stepped on in and she stole my heart. I couldn't believe it. This didn't happen.